It turns out that the capital asset pricing model, while having a fundamental impact on the theory and practice of finance, is not the only model out there. There's a number of other models that you should be familiar with that we go through in much greater detail in the second year course in investment and portfolio management. The first model that's detailed in the lecture notes is called the so-called Black CAPM. And this is named after the inventor of the model, Fisher Black, who published a very important paper in 1972 on this model. You might recollect that Black also was the co-inventor of the famous Black-Scholes formula. Now, the model of Black is similar to the capital asset pricing model in that there is one measure of risk, the beta. The main difference between Black's model and the Sharpe model is that Black's model does not assume that a risk-free asset is available to investors. So it turns out, in terms of our mean variance style of analysis, that if you recollect, we introduced a risk-free asset that simplified the problem in terms of choosing a portfolio of risky assets. When the risk-free asset was introduced, then only one portfolio turned out to be optimal. And that was the portfolio that was the tangency on the frontier. And everybody would lever up and down this particular portfolio depending upon their risk aversion. The Black model doesn't introduce the risk-free rate. There's no risk-free rate there. And Black argues that people invest along the efficient frontier, and any combination of efficient portfolios leads to another efficient portfolio. So the weighted combination of all of the efficient portfolios in the market turns out to be the market benchmark, which is also an efficient portfolio. And the formula for the Black CAPM is very similar to the formula for the Sharpe-Lintner CAPM, where we've got now an excess return equals the beta times the risk premium. The only difference is that the excess return is measured with respect to not the risk-free rate, but with respect to a portfolio that's got exactly a zero beta. Now, in the Sharpe model, the risk-free has got exactly a zero beta. In the Black model, there exists some portfolio out there that can be constructed to have exactly a zero beta with the benchmark. So that's the another model that's of use. But what I want to focus on is not the Black capital asset pricing model, but the multi-beta asset pricing model. And this is sometimes referred to as the Arbitrage Pricing Theory, which was invented by Stephen Ross in 1976, and sometimes called a multi-beta or multi-factor capital asset pricing model. And certainly it's the case that William Sharpe was very much involved in extending his model to the multi-beta context in important papers in 1982. And also there's some papers that I would refer you to in my second year course, one by Robert Merton in Econometrica in 1973, and the other by Long in the Journal of Financial Economics in 1974. All of these papers have in common a multi-beta type of asset pricing model. So let me give you the intuition. I'm not going to go through the derivation of these models. I just want to give you the intuition of the models, and these are models that are used in the second year elective courses. So first let's talk about a multi-beta CAPM. The first thing is, why do you want to go to a multi-beta CAPM? Why not use the simple Sharpe model that's rich in intuition, rich in economic foundations? Well, there's a couple of reasons. First, it seems, how should I phrase it, rather heroic to think that we can summarize all of the characteristics that we need to know in terms of generating expected excess returns in one number, the beta. This one number completely characterizes or completely differentiates one security from another security. Remember, the premium, the risk premium that's associated with beta is common across all assets. So the only difference is the beta. So I can completely determine the difference between two securities by looking at the difference in the betas. So that's a lot to ask for in terms of a model. Remember, economic models are designed by construction to simplify the world. The world is too complicated for us to really understand how everything works. So we struggle to create these simple economic models that take a complex situation and make them understandable. And that's exactly what the capital asset pricing model does. It takes a highly complex situation and simplifies it to a single number, the beta, and of course the risk premium. Now, as is true with any economic model, you give me enough data and I can reject that model. It makes sense because with enough data, and given that I know that the model is a simplification of the world, given I know that, with enough data, I should be able to reject the model. So by rejecting the model, it might be I find a number of securities with the same beta which have different return characteristics. Persistently different return characteristics. So find securities with the same beta, let's say 1.2, and one security has an average return 25%, the other 20%, and the other 10%. Well, this suggests that the capital asset pricing model doesn't fit the data perfectly. Now for me, that's no surprise, because I know that it is a simplification of the world. And that doesn't mean that I'm not going to use the capital asset pricing model, because indeed I will. Because in many cases, it is quite an adequate description of the world. So, let's go to a more complicated model. And it makes sense that if the capital asset pricing model is really simple, because it's only got one source of risk, that the next logical thing to do would be to look at more than one source of risk. So the idea of the arbitrage pricing theory, or the multi-beta CAPM, was to specify more than one risk factor. And what I mean by risk factor is simply something that we get a beta against. So for example, one popular style of model that was introduced in the mid-1980s was a model whereby we looked at certain macroeconomic variables and assessed the security's sensitivity to those macroeconomic variables. Now let's just take one. Let's take inflation, for example. So we could estimate a simple linear regression with more than one factor. So we would regress the security J, on, let's say, the market return and on the inflation rate. So the beta on the market return tells us how the security contributes to the variance of the portfolio, and the beta on the inflation rate tells us the sensitivity of the returns on this particular security to changes in the inflation rate. So you can think that this might solve the problem that I detailed a little earlier, that we've got three securities, they get the same beta with respect to the market of 1.2, but one has got a 25% average return, the other's got a 20% return, and the third's got a 10% return. Well, it might be the case that while these all have the same market beta, they've got much different exposures to inflation. And it might be that the 25% average return security has got a very high exposure to inflation. It means it's very risky with respect to unanticipated jumps in inflation. And hence, there's a reward for bearing that extra risk. So everything falls within the same paradigm of risk and expected return. All we're going to do is to modify our view of what risk is. So in this case, we've got the usual beta with respect to the market, and then we've augmented the model with a second beta. And actually, people go beyond the second beta and often look at maybe 5 betas. People have looked at the oil beta. And that was quite popular in the 70s when there were a few big oil shocks. People look at industrial production and the economy as a whole to get kind of like a GDP beta. People look at interest rates to see how securities interact with interest rates. There's many different possible sources of risk that we could measure beta with respect to. Now remember, we're going to use the basic same methodology that we did with the capital asset pricing model. We can obtain betas for the securities, and then there's a common, and this is very important, a common reward for each type of beta. And this is the risk premium that's attached. In our example, there would be a risk premium that's attached to inflation. And is common across all securities. So this is a popular multi-factor formulation. Now let me tell you about one additional multi-factor formulation. And that is a fairly new model that has received considerable attention in the press. And it's the so-called Fama-French Three-Factor Model. And this is the Eugene Fama, who is kind of the father of efficient markets theory and many other very important dissertation or advances in finance. So what this model is 3 factors, as I said. The first factor is the standard factor that you would find in the CAPM, the excess return on the market portfolio. The second factor is a factor that they call distress. So what they do is they form portfolios of securities and rank the securities based upon the ratio of book to market. And what they do is to form a portfolio, this distress portfolio, which is the difference between the low book to market portfolio return and the high book to market portfolio return. And the idea is that the firms with very low book to markets are likely to be the ones in distress. So they call this a distress factor and estimate betas with respect to that factor. And there's also another factor that they have in there, and that's a size factor. So again, they form portfolios based upon market capitalization and look at the difference between the smaller stock portfolio. Actually, it's the difference between the high capitalization portfolio and the low capitalization portfolio. And they call these risk factors, and you can assess betas with respect to them. And actually, a number of practitioners will provide a beta book based upon the Fama-French Three-Factor Model. Again, it's the identical intuition as the capital asset pricing model. We've got risk exposures against these 3 factors. We've got common rewards for risk. against each of these factors. With the betas and with the risk premiums, we get an expected return. The expected return is basically the reward for risk. All these different models do is to redefine what the risk is. It turns out in many cases these models deliver very similar predictions. So the simple capital asset pricing model does a very reasonable job in many different situations. However, in other situations it doesn't do that great of a job. So there's some merit to this area of research, and let me stress that this is research that's ongoing. That I guess with options pricing theory, we've got this really clean model that determines the price of a derivative security. With asset pricing theory, there's much still to be learned. And this work is of very substantial importance. Just the simple capital asset pricing model earned William Sharpe the Nobel Prize. The implications are very substantial in developing a better model. And a number of researchers, I guess including me, have embarked upon research programs to try to develop a better asset pricing formulation. There's still much to do, but what we've got is very substantial and very relevant and useful in terms of the practice of finance. And the evidence is really quite rich here in that almost all practitioners of finance use at least one of these asset pricing models to help them with investment, to help them with project evaluation, to help them with performance evaluation.